Tracing list notations. Did I not? I guess I did not do that. Alright, let's see if I actually understand what I'm talking about a little bit, or if I am already full of it. Let's writing a program to keep track of names on a wait list. She wants to remove Paula first from the waitlist and add someone named Adam to the end of the waitlist. After the value waitlist should be Adrian, Jolene, and Adam. Alright, pop, remove the item at index for list and return its value, and returns value. And append. So waitlist pop 0, append Adam, or yeah, just append. Cool. Consider the following program. You got order quantities and a list. Order quantities pop the third index, so 7. Ordered quantities insert at index 1, 50. Right here. So 3, 50, 4, and 3. Oh wait, pop the third one. It was an append. So pop third index, which is 4, or which is 7. So there should be a 4 here, and 7's gone. Like, there, think about it. 0, 1, 2, 3. And returns value. Pop 3. Uh, insert element into list at index 1, or at index I element. I mean 3 will always be there. So is it this one? Why is it that? So I was confused because pop, I guess, where's the value? Hey, I don't understand pop. I think it's created a list in order. So 3, 1, 4, 7. Next pop. Alright. To remove the value at index 3. Okay. From order quantities. After this line executes, the values of order quantities are as follows. 0, 1, 2. So yeah, there's no 7. They remove the value at index 3 after list. Next line runs. Quantity insert. Oh, I think insert shuffles. Okay. Because it shifts everything. One index is shifting all subsequent values down one index. After this line executes the values of. So because I got rid of 1, so it's not 1 doesn't get destroyed from insert. It shifts upward. So alright, I remember now. So I was full of it. I did not remember what I read last time. Define get adverbs, adjectives, set a empty reference, or whatever they want to call this type of thing. I don't remember. For adjectives and adjectives, verb, append, adjective, adverbs, the thing, append ly to whatever's in that. Return adverbs, and then that's going to be the whole list. So 4 in that. This is not a length. This is not a length of the adjectives list because I don't know. Why is it not for adjectives in length of adjective? I guess adjectives is just a list. So we could just say in the list. And that will give you a for loop that will tell you how many times to loop through accurately. Okay. I guess, yeah. So why do we need to use the length of a list or the length after in a for loop? Why do I need to use a list? Let me look back at what that is. What I'm thinking of in reading in range size. So 4 steps in range size, and it can't just be because that's defined here in size. So in a definition, well, this is takes in readings. What if I just say like sizes? Sizes is not defined. Did you mean size? So sizes is not defined. And what if I just define it here? Say sizes is, I guess not a, but it's a list. Got an index. I guess it should, whatever. I don't know. Let's see what that is. Unexpected indentation error that it does not match any outer indentation level. What? Indentation error in an expected indent. It said in all the indentation errors. How did I sizes is I don't know 0. Alright. Outer indentation level. Anyway, we'll mull on that later. That didn't answer my question, and it wasn't going to. I'm a very good student. I ask a question and then I answer it with a completely different thing that wouldn't answer the question at all. Bilal is writing a program to track which rooms are available in an office. Available rooms is this list. He wants to add room 310 to the end of the list and remove 130. Okay. After this, the value of available room should be 101, 270, and 29, and 310. He wants, yeah, pop and append. So he wants to pop index to 1. Should you not pop first? Does it matter? I guess not. And then append. That's how that's written. Ratings is this list. Ratings insert at index 1, 3, which will shuffle, and then pop index 2, which is wouldn't that just be the index that you just put in? 0, 1, and 2. Insert at index 3, so that's the final element. Or no, index 1, insert a 3 at index 1. So 0, 1, 2. Right here, shuffles 2, 3, 5, 4. Then pop up the second one, so that would be 2, 3, 5. So 2, 3, 4. Count words results is this blank one, list, appending list, or whatever. For word in words, taking in words right here. For word in words, if length of word is greater than 5, result, append word. So if the word is 5 or more, it puts it in, return result. Okay. Which statement best describes behavior? Find words. It modifies words by removing all elements from it with a length of 5 characters or no. Returns a new list containing all the elements of words with a length of 5 characters or less. No. Modifies words by appending a copy of every element longer than 5 words to the end. Doesn't modify it. Return a new list containing all elements of words longer than 5 characters. Yep. Video.
Let's design a program with lists, the accumulator pattern, and string methods. We've collected flight data from several different airports. We want to do some analysis here to understand if there's any patterns in a particular airport's delays, and maybe to see which airline is the biggest offender. Before we try processing it, let's understand our data format. Here we have a table of past flights. For each flight, we have the date, the airline, the flight number, and a bunch of delay fields. The delays are all represented in minutes. For now, we're mostly interested in departure delays, that is, how long after the scheduled time the flight took off. When we download this data, the computer puts it in CSV format, where the columns of each row are separated by commas. I did some quick work to get that data into my Python program, and now I have a list of CSV strings. Each element represents a row of the table. To start, let's create a new module to hold all of my analysis functions. I think I want to calculate the average delay time per airline. So I probably want a function that takes in the name of an airline, our flight data, and returns out the average delay for that airline in minutes. To make this easy, I can just accumulate a list of all that airline's delays. The average then is just the sum of that list divided by the length of that list. Remember that each element of flights is a CSV string, so I need to parse that string to get the airline and delay info. To get a list of all the fields, I can split my string based on the comma separator. And if I check my data format real quick, I can see that the airline is in the second column. So that'll be index 1. If the airline doesn't match, we skip it. Otherwise, we need to know the flight delay. The departure delay field is going to be at index 0, 1, 2, 3, 4. So I extract that field and append it to my list. Let's go back to the main file and test it. We import both our modules, and then pass the flight data into our getAverage function. For now, we'll just pick a test airline, let's say Delta. Oh, that's a type error. The stack trace says it's coming from the return statement in my getAverage function. Weird. Let's print the state of my list right before that line. Okay, these are strings, not integers, and also weird that there are some negative numbers in here. but one thing at a time. The type error is definitely coming from the string thing. So if we want all these values to be integers, we should cast them before we append them to the list. Great. Now, where are those negative numbers coming from? It looks like our data does have some negative numbers in the departure delay column. My guess is that maybe this means that the flight left early. But if I'm talking about delays, I don't care if the flight left early. I don't want negative numbers to be skewing my delay average. So I think I want to treat those as zeros. If the flight left early, there was no delay. All right, we have this working for one airline, but I want to compare the delays for all airlines. How do I know which airlines to check? Well, I'm going to run this analysis on data from a bunch of different airports. And the airlines that fly out of each airport are different. So the best source of truth is the data itself. Let's write a function that iterates over the flight data and collects a list of unique airline names.
Okay, that's a completely different concept. So, okay, let's stop here for a sec. Returns the average departure delay for the given airline. We can cast, we're trying to find delays. So, returning an average. So, we need delays, the sum of delays, rounded by a delay's length. So, the main part is just delays, is the whole point of this function. So, for a flight, in flights, yeah, and that's just the formatting for a for statement in Python. Fields, we could split it, and that gives you a lot of, from the CSV, it splits everything, and just gives you a big old list of a lot of values. And then we're saying, hey, that's a field, like everything there is fields is now a list of things. Now we filter from that and say, hey, if it's fields, this has the airline information, and it's not equal to an airline, this is the filter. So if fields is split, if fields is from that and it's not an airline, then if it somehow is in the airline field that should only have airlines in it, go through this until it hits an airline. Delay gets created as a thing. Because then it's in
So we start with an
fields, whoops, fields 4. It's in the fields information, it's in that, it should be in indice 4s, uh, index 4, relative to this. I guess, how does that work? Because fields of flights, field, oh, yeah, because fields is already, hmm. How does it know that every index 4 is the right information as it goes through all of it after it's got split up by fields? After that, I don't know. That's a question. So then you cast it to an integer, and because there's some negative, we just take the max. That's all that. And then we've used this. Say, hey, let's create. It's in this thing. Delays. Append delay. What we just made right here for that purpose. Append it. Boom. And then that creates the delays list, which then you can use its sum and its length from only one thing to create an average. Cool. All right. That is what we are thinking. So now we are here on this one. Return a list of the unique airlines with flight data.
empty list, we accumulate inside the loop, and
Accumulate.
return the final list at the end. Okay, and on each iteration, we extract the airline name, which we know is at index 1, and then we append it to the list. But this is just a list of each row's airline. We want a list
Each
of the unique
row.
airlines that
So yeah, this gives a row. So that's how that works. I guess it gives you rows. It's pretty interesting. Okay.
fly out of a given airport. So if an airline already exists in the list, we don't want to append it again. Better, but not best. It looks like maybe our data has some different capitalizations of airline names. So they're getting counted as separate airlines. Now, we
Hmm.
could just convert all the airlines to the same case inside the find airlines function. But the get average function is also using the airline name, so it must be affected by the same issue. Instead of forcing every analysis function to recognize and handle this data inconsistency, we can use a step called pre-processing. This normalizes our data once up front, so the rest of our
Import pre-processing.
code doesn't have to think about it. We'll create a new module for this, since this is a different class of functionality. We iterate through each flight, normalize it, and append it back. To normalize, I'm going to convert every airline name to all uppercase. Now, one other thing, we also had all those negative delays that we converted to 0 inside the getAverage function. Now, I think for all calculations I'm going to do, I don't care about early departures. So I'm going to move that 0 conversion out to the pre-processing step too. That way no one else has to worry about it. We call this pattern separation of concerns, because each piece of code can focus on a single task. Our analysis shows that JetBlue has the worst average delay at this airport. To continue on, we can analyze the delays at other airports, or maybe add a function to learn more about delay causes.
All right. We have pre-processing a form. Okay, so this is just data. Pre-processing functions, couple functions, and then main. What are we being asked to? Naveen is collecting t-shirt orders to celebrate his company's big feature launch. He posted a t-shirt order form, which has a link. Okay. For folks to fill out with their preferred size, colors, and monogram. A monogram. Okay. I guess I'll just, I don't know what that is. Not explicitly, monogram. A motif made by overlapping and combining two or more letters or graph themes to form one symbol. Oh, so like DC. Alright. To process orders for the t-shirt vendor, Naveen sets up the order search module. So that's where we're starting. Then he downloaded the list of responses from the form. This is comma separated data with names, office, location, shirt size. Okay, so each element of the list represents a form submission with the fields: name, office, location, shirt size, shirt color, monogram, date submitted. LL larges, MJ, oh XL. So now we can discriminate. Emma Wilson, you are deleted. Get out of here. Sorry, you didn't make the cut. Yeah, I'll just destroy you. Should have been trying to buy an extra large. Um, I'm being silly. I'm being ridiculous. I am delaying myself in reading. Each response comes with a string. Fill in the filter by size function to return an updated list of responses that match the size parameter. Is there any reason to like have this data be so large when I'm just trying to learn a little bit and get a grasp of what makes sense and what doesn't? Who cares? All right, we're not gonna think about that. Only a couple days. Yeah. Fill in the filter by size function. Gives responses. It uses responses and size. Returns only the responses that match the given size. The given size. The given color. What is that given? The given size. I mean, this is a filter. Order search. Filter t-shirts orders according to selected criteria for easy lookup. Mm, Updated list of responses that match the size parameter. Get the known Get to know the data format in Form.py, then trace through how filter by color works. Your implementation will follow a similar pattern. So we're gonna create a filtered, because this is also a filter. So what? Um, I, yeah, okay. I mean, so for response, yeah, actually, that should just be so for responses in blah blah blah. That should be the same because we're just, okay, maybe not super tabbed. Unexpected indent token. Why? What is there? No, it should be. It's right there. What is happening? Just go to the right spot. Thank you. Anyway, we're splitting that data. And if the field of what are we looking at? Sizes? The sizes is 0, 1, 2. Here's the size. 0, 1, 2. Cool. So if it's that one, it is a size. It is a size. So filtered gets appended, and filtered, dot append, the response, because we're taking responses as well. Response, not responses, response gets cast right here. So it's response in responses. Also, I didn't spell response right. That would help. And then just return responses. Return responses. Oh, or this is the other way. Return only the responses that match the given shirt color. Return only the responses that match the given size. Um, hmm. Also, unexpected indent. What is that? These aren't unexpected indents. I don't understand why I'm getting indent. Token indent. Okay. For field. That linter. Field. That's the if fields. Yep. Alright, the linter is working. I'm just can't type. Does that doesn't work because undo any changes to forms up high. Okay, well, let me just save that, I guess, and we'll start over because I don't remember. I did modify it just because I thought it'd be funny, but they got you. They catch on. They catch on. Why is it just? Oh, never mind. Anyway, unexpected indent. Yeah, I don't know why that's indented either. Alright, no, not quite, because with a few test cases, see what is missing. Well, what's missing is that this is not filtered by size, filtered by color, it's green, prints, green shirts, green shirts and size upper, green shirts. Okay, what it just makes it uppercase. Hmm. I don't know how to do test cases very well or at all, actually. I don't, yeah, yeah, I think that's really what's missing. Is confidence of just using the functions with something. Because I have no idea how to make a test case. Call filter by size with a few test cases to see what happens. Alright, green filter by size, order dot search filter by size. So, and we're just gonna say test, and I don't, green shirts, and it takes in responses and size. I don't know. I've I ran out of confidence. But we're filtering not by responses. So return only the responses that match the given side. Filtered append the responses. Response and responses for that for two. to a size. I mean, if we do that, it's gonna not work. If we do that, it's not gonna work. You know, okay. Yeah. So I think we were right. Shirt size, shirt color. How do I make a test case? If responses and size are true, append responses, append filtered, append responses, return filtered. Why did I have response down here in the first place? I don't know, but now it works. What was broken before? Just didn't work, and okay. 36. Oh, I just dumped the 36 value over and over and over. And now I understand what this is doing a little bit better. Order 2, excess, and then make sure. Anyway, insert missing a color. Originally, Naveen planned to order all green t-shirts in response to feedback. He later added a few color options. Green, blue, or pink, because the form didn't initially include a color question. Some responses have no entry for color at all. Cluster to normalize form responses. By backfilling the color field and a response has no color choice, he wants to insert the value green to the response if it has no color choice. So we need to figure out if it has a color choice. If it doesn't, we insert green, and then we continue on throughout the whole list like that. So modify the normalize response function to insert green into the responses if it has no insertion. Fields, response, lowercase at all, and split. 3 letters. Field, fields, -2, and index, which is just the same way of saying this one, because that's -1, -2. Fields at -2 that are equals fields there, and it caps it at 3, I guess. It just takes the first 3 letters and uppercases them. Okay. Return. It returns and a join. And it joins wherever the commas were. It joins them back up and return spits out a new fields data. So everything we're doing is for fields here. Woo! So green into the response has no t-shirt. So return a normalized version of responses for easy comparison. It's been lowered, it's been split. So this should now have, because some of them just don't have it at all, like this one. Green, green, green. A lot of people still pick green. But yeah, shirt color. This one, for instance, doesn't. So it only has 1, 2, 3, 4, and 5. While this has 1, 2, 3, 4, 5, 6. Note the diagram field is optional and may be blank. Monograms can also be gone. So, and nothing. Anyone with that and no color choice as well? And so again, interesting. Interesting how I deal with nothing. And I guess we just have to write something at the start, but I mean, it's like I guess we could just do a filter, caps, monogram to 3 letters. Um, if 4, would it be a 4 in blah 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 blah? 4 blah blah and blah blah blah. Is that not right? 4 responses and responses, response and responses. 4 response in responses. If I don't, I just want to think about the index, and if say like if the index is gone, throw green in there, and that, yeah, alright, I'm gonna duplicate teacher resource. Alright, product reprocess, so normalize. Oh, this is, okay, so it's not that long, it's just an if statement. Is it? If length of fields is equal to 5, field insert. Why does that work? Fields. If the length of fields is equal to 5, fields insert. Oh, because that's okay, each row is called fields. Or each row, yeah, each row thing is fields. So if this is, but I mean some data has, there's some that have 4. What about the ones that are four? Right? Is that not? If response is missing a color choice, if length of fields is 5, fields insert at 3 that will shuffle things around. But I'm fairly certain there's some. No, wait. Monogram can be left blank, but that's still a field. Alright, because it's still, like, this is still a field. It's just blank. So, if I inserted something here, this blank would be shuffled forward or backward or whatever. Yeah, forward, I think. Now I get it. So this is just, okay. So I can just filter by the rows. So I was off my board here, not all in the right place. So fields is if fields is equal to 5, append append blank blank append green. Put something on the field dot append green. Right? Is that not how you do it? Insert. It's not an append, it's an insert for one. Insert. Wrong operation. And it also has to be and if it's an insertion, you have to specify where to insert it, and this also has to be clearly show that it's a string. And yeah. If and also it's not the length of fields. It's not the length of fields, it's yes, if the length of fields, this is mine or this is sample. If the length of fields is equal to that, insert fields dot if the if the length of fields, uh, because if fields is equal to 5, it'd be like if the field entry was 5, if the variable field equaled 5 as an integer, we would insert. Yeah, I don't know if that makes sense. Yeah, alright. So that just wouldn't work. It would never get triggered. Responds to the form multiple times. Has budget for 1 t-shirt per person. To handle this, Naveen decides to deduce to dedupe the form responses based on a name. If a response uses the same name as an existing response, he wants to remove it from the list. Fill in, remove duplicates. Choose which response to include. Already normalized. You'll want to keep track of which names you've already seen. Okay, so I need to say uh, duplicates, and we're gonna make a new thing, and then we're just gonna gather in the duplicate names. Duplicates for a list, we're expecting stuff, and then say blah 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 blah, and then append to that list, and then say like pick if the first one that we process, we'll just dump that and dump that as a response, right? So yeah, I don't know. This is two. For blah 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 and responses split at that deduped and names. Oh, we need to do two. So let's just where's the word deduped even, man? Deduped. Deduped. Meaning. Data deep duplication. Deduplication. Deduped. Okay. Q. Cool, cool. Yeah, my tags are lies. I did list the responses with exactly one. So we have a deduct to do that, and then we say names, and we look, and then for and then if in name is gonna come from splitting it, it's normalized. It's at 0, which is the first one, and then we say, okay, well, for blah 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 blah. We have names is gonna be that or name, and then we say names if a thing cast it to names, right? Is that not the structure? If name in names. So for this, skip if we already have a response with this name. If names in names continues. Return to duped. Return to duped is responses, names append name. Why is this skip if we already have a response with a name? So for this, we're just collecting names. If name in names continue. If names, if names, if name in names continue, right? I got my indent's wrong, I guess, I don't know. I double indented. And then return, wait, what? this works by the same thing like this. If field is exactly size. Oh wait, no. So so it's whatever that. So if name is in names, we skip it, right? If name is in names, dedupe append, where we deduped gets appended with response every time. So we're doing okay, to dedupe, the dedupe. This just solves that. Gets appended. So dedupe dot append. That's how you do it, right? Dedupe gets appended with responses. Responses. Alright. Responses. And names gets returned. Or name gets returned. Or names. Yeah, return names. Right? No. Also, it's not built-in function or method object is not subscriptable. That's not from pre-processed. 31. It's not subscriptable. I probably just wrote that wrong, right? Dedupe dot append response. Oh, I said responses instead of response. Right, and then dot append. Oh, and then return names. Not quite, because reboot dev is with a few test cases. See what's missing. Ha ha ha, yes, so let's say every time. Yeah, I had a feeling, right? The duped. So let's just look at it again. The dupe gets created, names gets created. For responses and responses, for the rows, we throw that into name. If name is in names, it gets continued. So it keeps doing its thing most of the time, and then it hits a thing, it continues. Deduped is uh, also being incremented, and it gets that, and then we return names. Should we return deduped? Or, no, yeah, return deduped. Oh, and also names gets the thing to names. Oh, so it actually works, and not only once, because this doesn't increment, so this never activates in the first place. The names got append. The filter doesn't work if you don't activate the filter with responses, or yeah, response with response, right? No, with names, because that would just make everything filtered. With name, with the name, and then we return the duped, or and then we return the duped, and we destroy white space. Cool. Wowie. So yeah, that the filter needs to be activated, or else you're not using it. Cool. This is probably way above my level. I'm already heavily relying on the teacher resource. It's not very good. I'm just not very good at this at the moment. But, you know. Um, that's gonna be all for me. Appreciate you for listening or hearing this message, hearing this bit for a second. Thank you, and have a good rest of your life, rest of your day.